Imagine a basketball spinning on someone's finger. A point near the middle of the ball takes longer to spin back to where it started than the spot where your finger is. Earth spins in much the same way. People in the center of Africa are turning at 1,000 miles per hour as the planet rotates, while anyone at the South Pole doesn't really move at all, other than rotating in place. At the same time, we're all moving forward through space equally fast, since the planet is also hurtling around the sun at 67,000 miles per hour. The temperature at the boundary of our planet's inner and outer core is 10,800 degrees Fahrenheit. That's as hot as the surface of the sun. And the pressure there is 3.3 million times the atmospheric pressure at sea level. 2 or 3 years ago, an asteroid was pulled into Earth's orbit and started to travel around the planet. Even though it's no larger than an average car, it's still a big deal. Out of more than 1 million asteroids astronomers know about, it's only the second one to orbit our planet. Called 2020 CD3, it's our temporary mini-moon. It won't be with Earth for long though. The asteroid is following a random orbit and is slowly drifting away. Temporarily captured objects, such as 2020 CD3, are rare. They need to have a specific direction and speed to be caught by Earth's gravitational pull. Otherwise, they either crash into the planet or fly in another direction. The movement of galaxies and clusters billions of light years away from us suggests there's some enormously massive body outside the visible universe. After billions of years, the expansion of the universe will make the space so sparse that we won't be able to see the stars in the sky at all. The moon isn't a perfect sphere. It's shaped like an egg. Plus, the satellite's center of mass is a bit more than a mile off its geometric center. Even though Venus is the hottest planet in our solar system, it still has snow. But not what you'd expect. It snows metals and rains acid. Not a great vacation spot. Saturn is mostly composed of hydrogen and helium, with some traces of methane, ammonia, and water. But it contains more sulfur than Jupiter, which gives the planet a smog-like orange hue. On Earth, sound waves make air molecules vibrate, which is why we're able to hear sound. Other planets and moons allow sound to travel through mediums like their atmospheres and oceans too. In space, though, it's said that there is no sound, since there aren't any molecules to vibrate and deliver sound waves. However, not all researchers agree on this, given that space isn't just a desolate vacuum. In between the emptiness, there are clouds of gas and other stray particles. So, depending on where you are, sound waves can be possible. Astronomers know for sure that the universe is growing bigger, and the speed at which it's ballooning is increasing all the time. But if the whole thing is swelling into something bigger, then it must have some kind of an edge, right? It's unlikely that people will ever find out, but if so, then what would it be? A ginormous brick wall and then nothing? An abyss that leads to nowhere? The most common theory is that the universe is shaped in such a way that it can't have an edge, but it's not the only idea. Another theory is even more difficult to comprehend. The universe is, indeed, infinite, and our part of it isn't that unique. It means that somewhere out there, there's another you, or rather, other you. One of them is just a bit shorter, another wears their hair in a different way, and the third one is identical to you in all possible ways. There's also a theory about a multi-universe that consists of many smaller universes, and the universe we live in is just a tiny bubble among other similar bubbles. Those scientists who support this idea are also sure that bubble universes can come into contact with one another. Then gravity starts to flow between them, and when 2 or 3 universes connect, a big bang occurs, just like the one that created our home universe. Neptune is the windiest place in the solar system. Clouds of frozen methane are whipped across the planet at a speed of 1,200 miles per hour. Neptune's core is solid and consists mostly of iron and some other metals. Its mass is 1.2 times bigger than that of Earth. The temperature inside reaches 9,000 degrees Fahrenheit. Astronomers also believe that at a depth of 4,500 miles, there might be a diamond layer where it's raining diamond crystals. On Earth, People are used to a beautiful sunset that's painted in hues of orange, red, and yellow. On Mars, however, the normally pinkish red sky turns blue as the sun goes down under the horizon. It's because Mars is much farther away from the sun than Earth, making the sunlight less intense. The fine dust in the Martian atmosphere absorbs the blue light and gets rid of the warmer colors that you typically see on Earth. Whether it's blue or yellow, both sunsets look spectacular. At around a quarter of the size of Earth, the Moon is pretty enormous relative to other satellites out in space. There's nothing quite like this situation anywhere else in the solar system. Pluto has a moon that's almost half as big as itself, but it's more like a twin than a satellite. There are more than 150 moons in our solar system, and Earth's is the 5th largest out of the whole lot. There might be a labyrinth of lava tubes on the Moon. Not long ago, astronomers received the results of an underground lunar topography. They discovered a massive cave under the satellite's surface. About 30 miles long and 60 miles wide, the cave's likely to be the result of 3-billion-year-old volcanic activity. After streams of lava hardened, they created a thick, hard crust on the outside. But inside, lava kept flowing, melting the rock and forming tunnels and caves. Countless pits in the Moon's surface discovered by NASA might be the openings to lava tubes. We can't dig up most of Earth's gold. 99% of it ended up in the center of the planet several billion years ago, attracted by the iron in Earth's core. We're talking about 1.6 quadrillion tons of gold here. That's enough to coat the entire planet's surface in 1.5 feet of the stuff. And if all those meteorites hadn't later smashed into the ground, bringing extra amounts of gold, it would be even rarer. Not so long ago, astronomers discovered a massive blob of some mysterious substance. It was hidden underneath the surface of the Moon's far side. Its mass was the same as that of a pile of metal 5 times larger than the big island of Hawaii. The enigmatic something lies almost 200 miles beneath an enormous crater that appeared on the lunar surface billions of years ago. The blob likely has something to do with a super collision. It might be the metal core of the object that hit the Moon back then. Scientists can't wait to lay their hands on the discovery. It could explain lots of things about the South Pole Aitken crater, the largest known in the solar system. If it was on Earth, its oval-shaped basin would stretch from Washington, D.C. to Texas. In 2011, astronomers discovered an enormous water reservoir simply floating in space around a supermassive black hole called a quasar. Floating water vapors have been found throughout the universe, but they aren't that common. This particular reservoir holds around 140 trillion times the amount of water in the Earth's oceans. It's one of the oldest, largest, and, at more than 12 billion light-years away, one of the farthest things known to humankind. Astronauts in space can lose about 1% of their muscle mass each month. To prevent this, they have to stick to an exercise regimen that lasts 2 hours every single day. The Milky Way galaxy and the Andromeda galaxy are going to meet in 3.75 billion years. They're moving toward each other at a breakneck speed. When the two galaxies collide, they'll form a huge elliptical galaxy. I won't be around then. Have you ever looked up at the night sky and tried to count all the stars? Yeah, good luck. Our galaxy, the Milky Way, has about 100 billion stars, but other estimates put it at over 200 billion, since calculating the exact amount is an almost impossible task, even for astronomers. As for the entire universe, there are at least 1 billion trillion stars. That's one with 21 zeros after it. For comparison, that means there are more stars in space than there are grains of sand on all of the Earth's beaches. The constellation Orion is the brightest one in the sky. Orion is also in the night sky during the winter months when it's dark for the most hours. This makes Orion the most recognizable constellation to almost everyone in the world. Most stars don't seem to move too much or change their positions in the sky. This is not because stars are static. It's because our sun is moving along with them at about 483,000 miles per hour. It's a grand parade orbiting together around the Milky Way. The 3 stars that form the asterism, or star picture, of the belt of Orion have appeared in the same position for many thousands of years. There's a theory that the ancient Egyptians used the belt stars of Orion as a template for the placement of the 3 pyramids of Giza. The brightest star in Orion's belt is the middle one, called Al-Nilam. That's where the 481-foot-high Great Pyramid of Khufu was placed. To Khufu's west side, and in precise alignment with it, stands the 471-foot-tall pyramid Khafre. That's exactly where the star Alnitak is directly aligned to the bright middle star of the belt. To Khufu's east side, where the dimmest star of Orion's belt, Mintaka, is slightly offline with the other 2 stars, is the smallest pyramid of the 3. Menkaure is 213 feet high and slightly offline from the other 2 pyramids. This one example serves to illustrate the profound impact that the constellation Orion has had on human history. Orion's heroic-sized figure inspired the ancient Greeks to create a tapestry-like story. It involves 6 other constellations spread across the winter, spring, and summer sky. Let's see what this story tells us. Orion is pictured as a hunter. Back then, hunting was a big deal. Hunters supplied food. So there's a lot attached to this constellation, the whole food chain in fact. In the sky, Orion is in combat with the constellation Taurus the bull. Except, Taurus is not really a bull, it's an auroch. Aurochs are extinct now, but they were once plentiful in Europe. Standing 6 feet tall at the shoulder with long pointed horns, aurochs were powerful and fearsome creatures. There's a cave in the country of Spain that is filled with gorgeous paintings of aurochs. These pictures date back to 15,000 years ago, exquisitely drawn with inks that have not faded over the course of 150 centuries. The bulges in the rock stand out in 3 dimensions as the shoulder muscles of the aurochs. The constellation of Taurus, the auroch, is also in the cave, with the famous star clusters, the Pleiades, on its back, and the Hyades on its snout. The internet has a thrilling virtual tour of this Cave of the Bulls, full of aurochs. Maybe it should be renamed into the Cave of the Aurochs instead. Recently, the full DNA signature of an auroch was recovered from a well-preserved auroch skeleton, and scientists hope to breed these animals back into existence. Good luck and best wishes to this attempt to revive an extinct species. Aldebaran is the bright red giant star that marks the eye of Taurus. Bulls, when angry, always get this blood-in-the-eye look. Does it make you wonder why the bullseye on a dartboard or archery target is always red? Creeping up behind Orion is Leo the lion. Lions don't just live in Africa in times long past. The Cave of the Bulls in Spain has a painting of Leo the lion. Yep, these prehistoric people were drawing the constellations of the zodiac. But that's another story for another time. Orion gets rid of both Taurus and Leo. And then the story gets interesting. Orion claims in his moment of triumph, "I can defeat any animal I want." Orion's boast becomes the center of this sky drama when Gaia, or Earth, decides to get involved. Orion's words resounded throughout the world. This may be at the time in prehistory when civilization was changing from a nomadic hunter-gatherer tribal society to an agrarian society. The latter developed villages and towns 12,000 years ago. The human population was increasing, and food supplies were diminishing. Something had to be done about Orion and all the hunters, or social development would be stymied. Now enter Gaia into the story, but not into the sky. There is no constellation of Gaia in the sky. Gaia is Earth. Born parentless directly from the elemental chaos, Gaia was the feminine personification of our planet, and the word itself means soil. Brightsiders may be interested in a modern scientific theory that also personifies Earth as a living organism. It's called the Gaia theory. It first appeared in the 1970s. The Gaia theory presents Earth as a biosphere, as if it were alive. The theory claims that all components of the planet work together as one totally interconnected dynamic system. This is called symbiosis, or synergy. Together, they produce the ideal conditions for life. Life adapts to regulate the atmosphere at 21% oxygen, the salinity of the oceans at a maximum of 24.7%, and planetary temperatures at 57 degrees Fahrenheit. To illustrate how life adapts to maintain control of the changes in planetary temperatures, the authors of the Gaia theory created the fictional planet Daisy World. Daisy World is completely covered by white and black daisies. When the sun becomes too hot, the black daisies start disappearing, while the white daisies increase in population. The whiteness of these flowers reflects sunlight, and the planet cools down. If the sun isn't hot enough, the white daisies reduce their population, and the number of the black daisies grows. The black flowers absorb sunlight, and the planet warms up. This is Gaia at work. It's basically the same principle that created oxygen and produced the ozone layer in the atmosphere. This layer helps to block the harmful ultraviolet light from the sun. Scientists have been slow to accept the Gaia theory because of the lack of convincing evidence. But these days, we have self-learning AI supercomputers. They can probably make it possible to integrate Earth's biological and geological systems. This way, we might get a clear picture of how the planet functions as a self-sustaining biosphere. Wouldn't that be something? Now we can go back to the story of Orion and see how Gaia took care of the problem Orion's boast created for the planet. Obviously, Gaia couldn't send animals fiercer than a lion or an auroch to subdue Orion. So Gaia went small. She chose a poisonous scorpion to do the job, and it did the job. In the summer, the constellation of the Scorpion crawls at almost the same latitude as Orion's foot. The scorpion may be a small animal in the same arachnid family as spiders and ticks, but in the sky, Scorpius is the 33rd largest constellation out of the 88 of them. There is a general rule that the larger a constellation is, the longer ago it was created by early star watchers. They had their pick of stars, first come, first served. And so, they made large constellations first and little constellations later. By the way, if you were the first in line at a buffet dinner, wouldn't you take big helpings and let the end of the line have the scraps? Think chocolate cake. Oh sure, I'll only take a little piece. Nah, I don't think so. In this story of Orion, we have a collection of large conspicuous constellations like Leo, Taurus, Orion, and Scorpius, which confirms the great age of the story. 3 smaller constellations, Lepus the hare, Canis Major, and Canis Minor, Orion's 2 hunting dogs, complete the Orion star tapestry and add an interesting subplot. What we have then is a fable of 2 different worldviews or cosmologies, that of Gaia and that of Orion. One is feminine and the other is classically masculine. One is committed to dominating the natural world, that's the Orion archetype. The other is committed to the survival of the planet against all circumstances, that's Gaia. The 2 may seem opposed, but perhaps they're meant to be complementary. Look, Orion and the Scorpion are on the opposite sides of the sky, one in the winter, the other in the summer. They act like 2 poles, north and south, of the same magnet, our planet. This is what we see happening these days. Science and technology are becoming more and more sensitive to the natural environment. Myriads of satellites are monitoring the biosphere of Earth. Gaia and Orion are starting to work together toward what the ancient Greeks called kalokagathia, or harmony. That's what we call synergy and symbiosis these days. Let's keep that synergy going strong. Our Sun. Scenario 1. Something strange just happened now. Every TV channel, the news, they're all talking about a black hole that came closer to us, on the spot where our sun used to be. You can even see an accretion disk, and the background of the sky looks kind of distorted, which means it got really close. Normally, black holes are so far away that we can't see them with the unaided eye. You can't even see them with a telescope directly. What's it doing here so close? And where's the sun? Did the black hole swallow it? The sun used to be in the center of our solar system, far enough not to burn us, but still close enough to give us light, warmth, and beautiful scenes when it rises in the east and goes to rest in the west. Hey, this one even rhymes. Well, it gave us life. The most massive body in our solar system contains 99.8% of its total mass. It's so wide, you could fit more than 1 million Earths inside of the sun. Maybe our sun turned into a black hole, but it's way too early for that to happen. I mean, that's how they form, when enormous stars come to the end of their life cycle and explode, which is called a supernova. They end up collapsing on themselves, becoming very small. It's a tiny size and a huge mass. That's what makes black holes' gravity so strong, and even light that comes too close can't escape. And all the stars in the universe are shrinking and will disappear at some moment. Our sun loses 4 million tons of mass every second, and eventually, the only energy left in the universe will be generated by black holes. A black hole is surrounded by dust, gas, and radiation. The radiation is very dangerous, so we hope our planet won't come near it. Our solar system doesn't have light anymore. No light and no heat either, so even Mercury and Venus will probably get covered in ice pretty soon, not to mention Earth. Do I need to say nothing will survive this new ice age? The only salvation might come from the accretion disk that spins so fast it generates heat, but that's too many chances to take. Still, at least if the black hole has the same exact mass as the sun before it, all the planets will remain in the same orbits, Earth included. But if it has a mass bigger than our sun, which is something our scientists are currently trying to figure out, then bye-bye, solar system. It was nice knowing you. Scenario 2. Oh no, what's happening? It was supposed to be a nice sunny day, but now you see darkness descending so abruptly. How come it's night, yet the clock says it's 2 p.m., and the moon looks different? The TV reports say our sun is gone, and due to some mysterious events, the moon is not orbiting the Earth anymore. It's in the center of our solar system now. We don't have much time left. Since the sun is not in the center of our solar system, we now have 8 minutes and 20 seconds to become aware of it. It may take millions of years for the sun's energy to travel from its core to the surface, but 8 minutes and 20 seconds is exactly how long it takes for sunlight to reach Earth. The light takes a journey across 93 million miles, which is the distance that separates us from the sun. We're not in the habitable zone anymore. The habitable zone is the distance from a star, in our case, the sun, at which liquid water could exist on the surface of a planet. Now that the sun's gone, its light won't reach us anymore, and our planet will gradually become a frozen, lifeless rock. Who knows if we'll have enough time to come up with some technologies that would provide us with the solar energy we need to sustain life on Earth. If not, well, millions or billions of years later, scientists from some other civilizations would explore it, trying to find evidence if life ever even existed there. It would be the same as we do with Mars and other planets in our solar system, trying to figure out if they've always been lifeless or if there might be a sign that some organisms used to live there. Something else, also vital for our life, travels at the speed of light. Gravity. Without the sun, for roughly 8 more minutes, the planets would continue circling the empty center of our solar system until the clock ticks and they finally drift somewhere into an unknown direction of outer space. Our moon doesn't have a strong enough gravity to keep us in place. It can't shine so brightly to give us warmth and support life. It's so far, we can barely see it now. Without the moon that peacefully travels close to our planet as it used to, we can see tides are getting lower incredibly fast. Oh, and it's becoming really windy. Winds are so much stronger and faster now. When things were normal, our planet sat at a 23.5 degree tilt, which is the reason we had changing weather and seasons. Now the tilt is so extreme, it's getting very cold very fast. And our time is almost up. People are screaming, everyone's in panic. We still have maybe 1 minute left until we sink into eternal darkness. Scenario number 3. We're not sure what exactly happened and how the life we carelessly lived yesterday came to an end. No one could predict it, but it seems that, out of nowhere, a giant neutron star took the spot where our sun used to be. It's not something we'd recognize on our own. We just noticed something was different, and the sun kinda got smaller and weirder. The rest we heard on the news, and no one knows how it happened. Maybe our sun is somewhere behind the neutron star, or the star pushed it out of our solar system and into an unknown direction. A neutron star is the densest space object we know about. It has almost twice as much mass as our sun, but it's all squeezed into a star only 10 miles, 15 kilometers, across, which is about the size of a city on Earth. A neutron star forms when a huge star runs out of fuel. It collapses in a big explosion. Its very central region, the core, collapses, which is why every electron, negatively charged particle, and proton, positively charged particle, crush together into a neutron, which is either uncharged or neutrally charged. We're in a very tricky situation now, basically waiting for our end to come. This neutron star has gravity 2 billion times stronger than the one Earth has. This means our new sun will pull all the planets in our solar system towards itself and eventually destroy them. It's already started. For the first time that we know of, the planets are leaving their stable orbits, attracted by the powerful force of the neutron star. It's becoming chaotic pretty fast. And it won't stop there. A neutron star rotates more than 700 times every second, which is incredibly fast. Our sun rotates once every 27 days. So, after it destroys all the planets, including us, this star will continue whirling throughout the universe at about 1/5 the speed of light. Maybe it will slow down and fizzle out with time, but maybe not. After thousands of years, many neutron stars begin to slow down and blow out. But that doesn't always happen. If it meets another star, it will orbit it and start to feed off its atmosphere until it collapses at some point and turns into a giant black hole. Our sun was going to burn out anyway. Until the neutron star showed up, the sun was 4.6 billion years old, which was about halfway through its lifespan. It had already burned off about half of its hydrogen stores and had enough supplies for another 5 billion years. It was eventually supposed to end up the size of the Earth. After running out of fuel, it would have simply collapsed. It would have retained its enormous mass, but its volume was going to be similar to that of our planet. No sun, no life, so the result would have been basically the same. But this way, it would have been a slow process. Who knows if humans would even inhabit this solar system in those times? But with neutron stars, things move towards the end pretty quickly, and it's way more chaotic. If the neutron star was going crazy somewhere far away in another galaxy, we'd only see it in the shape of a distant flashing light that we call a pulsar. But this way, boom!